Now we're going to use the first derivative test to determine whether we're increasing or decreasing at any points of that range. These are inflection points. Let me label that. Let me set up a new table here. We're going to go from negative infinity to negative 1, from negative 1 to 0, from 0 to positive 1, and from positive 1 to positive infinity. We need to pick out some test values, so this will be negative 2, negative 1/2, positive 1/2, and 2. Let's plug those into our equation here. For the first derivative, putting 2 into the equation is going to give us 4 times 2 squared, or 2 to the third, which is 8. So 4 times 8 minus 4 times 2. We don't need to multiply that out to know that that's for positive 2, my mistake. We don't need to multiply that out to know that that's positive. In the case where we put negative 2 in, this will give us negative 8, 4 times negative 2, so this is going to be negative 32 plus 8, so that'll be negative. So we took care of those quickly. Now let's do 4 times negative 1/2 third minus 4 times negative 1/2. This is going to be equal to, I'm running out of room here, 4 times negative 1/8 minus 4 minus 1/2 is going to equal positive 2. So this is going to be 2 minus 1/2, so that'll be positive. And now we can pull out these negative signs, make them positive, and we'll get the case for positive 1/2, and that is going to be minus 2 plus 1/2. This will be negative. So now the next thing we know is that we're going to be decreasing from negative infinity to negative 1. We'll be increasing from 1 to 0, decreasing from 0 to 1, and then increasing after that. So now we have quite a bit of information about what's going on with our graph here, so this allows us to sketch a graph. Let me bring one in and make it bigger. Alright, so let's say that this point here, let's make this equal to, let's do 2. This is going to be 1, negative 1, and this is going to be positive 1. Now I'm not entirely sure what the value is for the square root of 1 over 3, so this is just going to be about an estimate, but let's say it's around 0.6, I think. Alright, with this information, let's do our sketch. We're decreasing with concave down, and then we'll have a minimum. So we're going to decrease with concave down to have a minimum here. Now we start increasing until we get to our line for our inflection point. But at our inflection point, we switch from a concave up to a concave down until we get to our maximum at 0. And we stay concave down, but now we start decreasing. See, we still have concave down in this range, but we're decreasing. And this occurs until we get to our line again, where we stay decreasing, but we start going concave up. And then once we get to 1, we start increasing again. So without any knowledge of our original function, f of x, and finding any actual points, we know the graph will look something along this nature, with minimums at plus and minus 1, a maximum at 0, an inflection point at plus or minus the square root of 1/3. So that is the process that we use for doing sketching, and you can't get it any more accurate than this unless you actually plug some points into your equation for f of x there, which you are welcome to do if you like.